Hello parents, this is Mr. Vietas. We've been working on 7-7 now for about 3 or 4 days, and 7-7 concerns area and mixed numbers. And I find this a rather important lesson because it will be later used to find area in geometric shapes, and not only just whole numbers but also with fractions, so it's necessary that the students understand this model. To understand this, there's a few things to review. First, we're building on the students' prior knowledge of arrays, such as 3 times 4, 3 rows of 4, and the area for 3 times 4 is going to be 12. You can count up the squares in the box, and that'll be equal to 12. Building on that, we're now looking at area models. A simple example of this would be 30 times 120. We write the expanded form for both along the side and the top. 30 would be on the side here, 100, and then plus the 20 along the top. 30 times 100 is 300, and 30 times, so it's 3,000, sorry. And then 30 times 20 is 600. And then you would add those two numbers together, and that would be equal to 3,600. A larger example of that would be 100 plus 20 plus 5 for the expanded form of 125, and then 300 plus 40 plus 2. You would go through this and fill in the area for each part. So the 100 times the 300 would be 3,000, and then we have, that's 30,000, sorry. 1, 2, 3, 4, yeah, okay, and then that would be 3,000, that would be 200, and then you would continue filling these in, and then just as we did with this model here, you would just add up everything on the inside to find the total value. Now, this relates to fractions, and kind of the similar way, except now we're looking at the height and width of a known rectangle. So we're going to make this a taller model, like this. And again, we're going to use the expanded form. But using the expanded form in this, what we're going to do is we're actually going to find the improper fraction first. And as the students know, the first thing that we do is multiply and then add going around this way. So we have 4 times 3 is 12, plus 3 is 15. I'll write this right here. And the denominator is still fourths, and we're going to multiply that by times and then again plus going around this way. So 4 times 2 is 8 plus 1, and that's 9 fourths. Now, one of the important things for the students to remember is that since we're talking about height and width, the area of one box is going to be multiplied by its height of 1/4 and 1/4 and its width of 1/4. So the actual area of this one box is 1/16. Okay. Imagine if you have 1/2 by 1/2, that's actually just going to be 1/4. This is just an example. Okay, if you have 1/2 of a foot by 1/2 of a foot, the area of that one box is going to be 1/4. Okay, we're not using that. That's just an example. So now we're going to take the numerators, and we're going to use these for our height and our width. So the students have been using grid paper for this, but I'm going to draw this in with a narrower pen just so that it's easier to see. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then by 9, 1, 2, 3, 4, 5, 6, 7, 8. Draw one more at the end. That'll be 9. Got to fill all these in. Okay, so this should now be a grid for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 by 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this is going to be 15 fourths by 9 fourths. One whole is going to be 4 of these. So we're going to start off by doing this. Okay, so I can make all of these holes, and then this is another hole, and then I can fit one more hole. 1, 2, 3, 4 is going to be right here. This is another hole. And then what I'm going to do is I'll take a little bit thicker of a red marker here, and then I'm going to start boxing these off. So what I have here is a 4 fourths by 4 fourths, which is equal to 1 whole. Again, I have a 4 fourths by a 4 fourths, that's 1 whole. 4 fourths by 4 fourths, 1 whole. 4 fourths by 4 fourths is 1 whole. 4 fourths by 4 fourths is 1 whole. 4 fourths by 4 fourths, this is 1 whole. Now, the next part to this is actually continuing to fill in the holes. And there's other ways to go about doing this, but this is the way that I've been teaching it. So I currently have 6 holes. To make 1 hole, it's going to be 4 by 4. So that's using the array is 16. And so the students can either use skip counting or counting by ones. Counting by ones means less mistakes. So I'm going to count up 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This right here can be made into another hole. Do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This can make another hole, and just by looking at this, I can see I cannot make another hole, but I currently have 8 holes. 1, 2, 3, 4, 5, 6, 7, 8. Now, I have 8 holes, and what I have left over is 1, 2, 3, 4, 5, 6, 7 sixteenths. Now, using the standard algorithm, I can go back and check my work. And I'm going to do 15, let's do right here, 15 fourths times 9 fourths. I have 15 times 9, which is equal to 135 over 16. And again, the denominator, and the students need to understand this, the denominator is 16 because of this model here. We're finding the area, and so we have 1/4 times 1/4, so the area is in sixteenths. Okay, I'm going to erase that line underneath there. And then if my math is correct, then 16 should go into 135 about 8 times. So 16 times 8 is equal to 128. And then I'm going to take the 135 minus the 128, and that is equal to 7. And that is sixteenths. So switching this from an improper fraction to a mixed number, these answers are correct. And again, the reason for this model is to later understand how we can find the area in geometry when we are given fractions for the lengths, and we're needing to use a standard algorithm to solve. If you have any questions, please let me know.